Ladies and gentlemen, we are entering the realm of quantum world. Please welcome to the stage Dr. Sana Amairi-Pyka, lead scientist at the Quantum Research Center at the Technology Innovation Institute.
Welcome, everybody. You are so lucky to be in Abu Dhabi in this time of the year. It's my favorite period. And this period is a festive period, so you will see the streets decorated, full of lights. It's magical. It's actually so beautiful. It feels like you are living inside a Christmas tree for a few months. But there is more to Abu Dhabi than just that. If you get out a little bit of this shiny city, and not very far away, about 30 kilometers from here, you will enter an area called, or a region actually called Al-Wathba. And there, that area is famous for beautiful desert and the equestrian activities and the camel farms. It's a very beautiful corner, and there is much less artificial light, so what we scientists call light pollution. And there you can see that the sky is taken over in the beauty of lights, and with bare eyes you actually can see the Milky Way sometimes. So we go into these camel farms, and what we did at TII, we rented one of these camel farms, and we decided to make it a lab. We actually started the construction work there. This was done within 3 months only. We set up office, container office. We set up an observatory, a dome, and then just like that, we have one of the most advanced quantum laboratories in the desert, very much. In the heart of these quantum laboratories that we call Abu Dhabi Quantum Optical Ground Station, we have a 0.8 meter telescope, so an 80 centimeter diameter telescope that is a very good one, let me say. It's able to track satellites, but of course, you know, telescopes are mostly famous for taking images, so we did that too. So here I'm sharing with you some of the images we took. There's not much image processing here like astrophysicists like to do, but you can see that we do manage with only telemetric data to track the ISS and look at a lot of structure in the ISS, and it's really a nice thing to show. But this telescope is also equipped with high-power laser beacons as a transmitter of high-power laser, and it's also equipped with very sensitive light detectors, single photon detectors. And what these single photons are important for us. So actually, we do collect single photons from satellites to build up a quantum key. This is part of a protocol called quantum key distribution. Satellites equipped with quantum source can send us these single photons that is used for quantum communication or for quantum encryption protocols. Quantum communication is one of the most advanced technologies in quantum technologies. It leverages the quantum properties of single photons to exchange a secret key that is extremely resilient against cyber attacks and is also future resilient against quantum computer attacks. So if you want to exchange the single photons, you can exchange them with a fiber, of course. And you can send them, you've maybe seen this setup already when you enter into the venue through this quantum tunnel that we have. You can have a fiber-based network for quantum key distribution. But if you have long distances, then you have a lot of losses in this fiber because single photons have very low power. That's why if you are to build a secure network or quantum secure network on a global level, so for example, connecting embassies between different countries or connecting banks in different continents, you have to have a trusted node. That means this quantum source for your quantum key distribution or quantum receiver on a satellite as part of your protocol, as part of your quantum network. That's why we have this ground station, actually, is to be able to connect Abu Dhabi to a global quantum web. This is the large vision for us for this quantum observatory or quantum optical ground station. Now that we are able to collect the single photons, the other thing we can do is to collect and also to send optical power for high data rate communications. Actually, right now, a lot of nations are investing in developing ways of communication through lasers. This is advantageous compared to the RF communication we know today. First of all, because with optical signal, you can send much high volume of data. It's about 40 times faster than what we do with an RF. That will also allow you to gain time on this data processing. For example, if you have satellites collecting images for Earth observation, you will be able to communicate this data faster. That you can think about faster way of mitigating crisis, for example, natural crisis or fire, or to be able to exchange this data for backing up the satellites' images, for example. So you also win on latency in that. So our ground station will be able to connect also to free space optical communication networks as well. You can see now how just these photons, what we are able to connect, can reshape the strategies of the country in how they secure the communications, secure the data, and also how to mitigate any issue we have with the current RF communications. Another thing we were able to do with our ground station is to look at the sky and to look at the space debris. This is part of our involvement for space situation awareness. We're able, because we are equipped with laser, with optical laser in the ground station, to do something called laser ranging. So basically, you will know precisely where are the debris and how big they are. And then you can move your operational satellites from the way of this debris. So this is also a unique capability right now in the region. And yeah, we are very proud to be one of the first people to address these issues at TII. So I hope with this now, when you look at the sky or you visit the desert, you will remember that there is somewhere in the desert, in a camel farm, a very advanced lab being able to connect Abu Dhabi to quantum communication network, to free space optical communication for high data rate, and for cybersecurity also, and also for space situation awareness, among other activities. Thank you.